All right, so now we need to put some mathematics into what we are doing. For that, we need to attach numbers to position and time. To attach numbers and to do mathematics for positions, we are going to define what we call a coordinate system. What is a coordinate system? Well, let's look at this picture here to see the definition of coordinate system. In here we have an axis. This line here is an axis. We also define an origin as 0, right? So this is your origin. And we also define markers, labels, for certain positions along the axis. For instance, we have a marker here for 1 mile, 2 miles, 3 miles, and 4 miles, and so on. So now with this construct, we can specify the position of this car here, for instance, and we can say this car is at the position 4 miles relative to this origin here. We can also say this cow here, that cow is at the position minus 5 miles relative to this origin here. So the combination of an origin, an axis, and these labels, that is what defines a coordinate system. So here we have a runner, and in this case she started running from here, so this is the natural choice for your origin, this point here, and now the labels are going to be this 10, 20, 30, 40, 50 in meters. So we are going to use the convention that we label X for the axis. So this axis is going to be labeled X, and typically we specify the units that we are using in between these parentheses here. So in this case, she is at the position at this time, as it is shown here, she is at the position 20 meters from this origin here in this coordinate system. We also need to attach numbers to time, right? Here we have two motion diagrams. And so in this case, we have the origin of time. This is when you start your watch, for instance. So the origin of time is here, and then this would be 1 second, 2 seconds, 3 seconds, 4 seconds. Notice that the units that we are using are seconds. In this case, you can see that the car moves at a constant speed from here to here, and then it slows down from here to here. If we are interested in the whole motion, then the natural choice for the origin is this point here. However, if we were interested only in the time where the car slows down, then the natural choice would be right here, where the car starts to slow down. So now that we know how to attach numbers to position and time, we need to talk about changes in position and changes in time. Let's start by talking about changes in position and define what displacement is. So a change in position, and we are going to denote this by delta x. This triangle here is called delta, and this whole thing is called delta x, and this is the change in position. It's going to be defined as the final position minus the initial position. For instance, here you have this car that moved from this point to this point. So this is your initial position. This is your final position. The change in position for this car here would be what? Would be 0, right? That is your final position, finishes at 0, minus, and then you have 50, which was the initial position, 50 feet. So the change in position is equal to minus 50 feet. That is the change in position. If the car moved from here to here, for instance, then you can say the change in position delta x is equal to 150 minus 50, final minus initial, which is 100 feet. The change in time is defined similarly. So in here we have a motion diagram, and then we have the different frames in the motion diagrams labeled. So that is important. That is how we attach numbers to time. And then if this is your initial position and this here is your final position, then we can talk about this changing time for this whole motion, and we are going to refer to that as delta t, and that is equal to the final time minus the initial time. Similar definition. What is the final time? The final time is 6 seconds in this case. The initial time is 0 seconds, and that gives you 6 seconds, which is your change in position in time. So let's look at a simple example. So we have Carol. She's enjoying a bicycle ride on a country road, and the country road goes from east west, and then there is a water tower there. So we are going to define the origin of our coordinate system here at 0 at the water tower, and then we are told that at noon Carol is at the 3-mile marker right here. That is her position. And then half hour later, she's right here at this final position, right? So at the minus 2-mile marker, right? 2 miles west of the water tower. What is her displacement? Well, her displacement is just delta x, right? That is the change in position, the displacement, and is the final position minus the initial position, which is equal to what? Well, the final position is minus 2 miles minus the initial position, which is what? 3 miles. And all this gives me that this is minus 5 miles. So the displacement for Carol is this whole thing, which is minus 5 miles. The distance that she covered is 5 miles, but the displacement is minus 5 miles. All right. Thank you.